Angular Orange here with a tutorial on promises. It's going to be a short tutorial. We're going to go through 5 different functions. We'll show you the basic promise and a callback, a catch of the promise being fulfilled. We'll talk about, we'll look at an example where you consume a promise. We'll look at chaining of promises, and we'll look at running promises in a waterfall fashion as well as concurrently in a parallel fashion. Okay, so first, let's introduce what a promise is. It's a placeholder for a future value based on an asynchronous computation. If we come through on our promise, we get a result. If a problem occurs, we get an error, and there's a reason why we get this error. Okay, so there's certain states. There's pending, which is unresolved. There's fulfilled, which is resolved, and there's rejected, that is, or an error is thrown. So the promise states are the following. You have pending, and then there's true resolved states. You have fulfilled, where you get data, and or you can reject and have a reason. So a simple example would be, I'm going to make a web service call, and you use a promise to say, okay, we promise that you're going to get data back. If not, you're going to get an error back. You're going to have some sort of resolved state. It's either going to be fulfilled with data or it's rejected with a reason that maybe the connection is down. But the bottom line is you're doing the web service call asynchronously, and you continue executing your code with the assumption that you're going to have a resolved state eventually. Okay, so that is pictorially what it really means. And then also, if you fulfill it and you get data back, it's not that you could then reject it for a particular reason. Okay, it's either one or the other, and you have one resolved state, and after you get that one resolved state, it does not flip to a different resolved state. Okay, so let's look at the simple promise constructor. Okay, so you do a let my promise equal to a new promise. That is, you use the constructor, and what you do is you pass in a function that's immediately executed upon the instantiation. So once that happens, the function could have a resolve and a reject argument. And what we're going to do, just for simplicity, is we're going to do a console log my promise is executing, and then we're going to do a set timeout, and in our set timeout we use an anonymous function by using the fat arrow operator, and inside that anonymous function we do a console.log resolving my promise, and then we resolve successful result, and that gets resolved after 2 seconds, which means the set timeout and the anonymous function executes after 2 seconds, and then we log and we resolve. Okay, so then right after that, I do my promise.then. What I'm doing with that is I'm setting up a callback, and once again I use an anonymous function with the fat arrow operator, and basically when that result comes back, the resolution of that promise, I basically that comes in as an argument s, and I basically pass that s to a console log we received this particular object. In the case, it's a string, so we received this string. So the output looks like this. My promise is executing, and then 2 seconds later we see resolving my promise, we received successful result. Okay, so just keep in mind that you're running this asynchronous code, and you've got this callback catch, but it doesn't mean your code is still not executing and moving forward. So just be careful of that. And also notice I use this let instead of a var, and let has a block scope as opposed to function scope like a var, and also a var could have global scope, but the let is used for a more precise declaration inside a block. So for example, if I had a for loop and I had a let I equals 0, that I would be declared inside that block. So it's a little bit safer to use in TypeScript, and that's why I used a let. Okay, so let's move on. And so here now we're going to go through an example, and it's called promises. And I have here simple, but I'm going to start out with this simple example, and I'm going to go through all the different examples in my sample project. Okay, so let's look at the application. Okay, so, before I do that, what I'm going to do is, first let me explain what I did here. I generated a project called Promises. I used Angular CLI to generate that, and then some scaffolding happened, and all these resources were created, and I went and I extended the app component. Now, when I extended the app component, basically what I did is I created a bunch of methods. Simplest, basic, I introduced a chain function to exhibit chaining, and I have an async await function to demonstrate those features, and I also have another chain which is a little bit simpler to understand, and shows you a little bit clearer what chaining can do. Okay, so and then in my template, what I did was I have these methods with these buttons, and I just invoke the different functions, and I look at the console log just to show you what these particular functions are doing. And so basically I have 5 examples of promises, and I go through each one, describing each one. So now let's do one thing before we move on. First of all, when I created the project called Promises, I always do an ng-v to make sure that I'm using the Angular version that I expect. So in this case here, I'm using an Angular version 5.1 and TypeScript 2.4. Okay, so I'm good to go. So what I'm going to do is I'm going to start the project. I'm going to start the application. And npm start basically looks at the Angular CLI file and says, where's your driver? It's main.ts. Main.ts is bootstrapping the app module. That thing is bootstrapping the app component, which is a root component, and the root component has a UI component tree. In this case, it's just a root component, but there's a lifecycle associated with what happens here. So there's a number of things that have to happen. First of all, we do fire up the server. A Webpack is going to transpile the files and optimize them and bundle them and blah blah blah. So let's just move on. We'll wait for that to happen, but we're trying to fire up ng-serve here. Okay, so let's go back to the example. Okay, so let's take a look at the first. Well, let me just describe the component to you initially. Okay, so first of all, I have a component, has an app root selector, has an external template, an external style sheet. I export this class app component, have a title here which is called demo of promises, and what I do with that title is when the app component instance gets created and that attribute is there, I use the interpolation directive in the template to show that title. So let's go take a look at that really quick. Welcome to title. This is the interpolation directive which will render the value of title at any point in time. So it binds title to the template. So title could change anytime and would see the new result, but right now all we're doing is instantiating the component, and by default when the instance comes up we have this title value. Okay. Now what I'm going to do is I'm going to focus on the first function. It's called simplest, and basically what I do is I log the beginning, I log the end. So I have begin simplest, end simplest at the end of the function, so I could see when I begin and when I end the function. I do an instantiation of the promise, and I pass in a function, and my function does a log. My promise is executing, set timeout, log. And then the set timeout after 2 seconds will invoke this particular anonymous function, and that anonymous function does log, resolving my promise, and it does resolve, and it passes in a string. So notice my function has resolve and reject, and the reject is not mandatory, but I need to resolve this promise. So it's very likely that it'll be successful. So I just resolve and do a successful result. So what'll happen is after 2 seconds, this particular anonymous function will execute. And so what you should see when the button first gets invoked and this method gets hit on, the first thing you'll see is begin simplest. You'll probably see the end simplest because this code executes the whole method, and then there's some asynchronous stuff that responds, right? So in this particular case, this gets resolved after 2 seconds, and the function executes much faster than that. So basically, you'll see my promises executing, and then you'll see resolving my promise 2 seconds later. And then all of a sudden I'll do this. My promise then. This is the callback. When it gets resolved, give me the string, and I'm going to log it. Console.log. We received the string. And simplest. So now let's go back and take a look at that particular function, how it executes. Like I said, begin simplest logs, end simplest logs, and all this other stuff is asynchronous. This is happening, and this is waiting for the callback. So we should be able to see what's happening. Okay, so let's take a look and see whether my function. Okay, so it looks like my server is now up. Webpack is bundled. And it has put that in a virtual directory, and now the server is running that code, listening for changes, etc. So let's go to the browser. Do I have a browser? And let's go and do a localhost 4200. Okay, let me try to make this a little bit larger. Okay, so what I have here is I have the template, which is showing for the root component. I guess you could see the index.html up here. It's a Dodge blue, and my root component is a light sky blue, I believe. And then I have this other. I guess this is a div tag, which is a container. It's a flex container, and I've laid out some buttons in there in a row fashion, so they're showing up nicely uniform across the screen. And I have these methods here that I'm invoking to show you some examples of promises. So let me go here and do this, and let me go to the console. And I'm going to, first of all, let's go back and just verify that what I'm doing here makes a little bit of sense. Okay, so I showed you I have this template and I have this button, and this is a directive called click, and I'm going to invoke the simplest function here. Now I do have a div tag, which is class actions, and in the process I have an actions class here, and I display it as flex. I do a flex wrap, I do a flex direction row, and I align items in the center. So I'm just laying out all those buttons, and notice I have a light green here. I also have a main class. Let's see what my main class is. Up here, this particular div is a main class, and that thing is a light sky blue. Okay, so the bottom line is I'm just showing you this user interface here, and so let me invoke the simplest method here. Oh, it says begin simplest. My promise is executing. End simplest. And notice my promise is executing was displayed when the promise was instantiated. I passed in the function. It started executing immediately. So my promise is executing happened to log. The end of the function, simplest logged, and then the async result, the timeout expired, and basically after 2 seconds, my anonymous function started executing, and it said resolving my promise. And then the callback got called, and it said we received a successful result. Okay, so let's take a look once more at the function. Okay, so simplest. We begin the simplest. This new promise got instantiated, and this function started executing immediately. My promise is executing managed to log before the end of the simplest, but this set timeout got submitted, and it's not going to execute for 2 seconds. So after this end simplest happened, what happened is resolving my promise logged, the resolve happened, the callback happened, and we logged we received. Okay, so let's go back and take a look at it again. Okay, so basically, let's go do it again. So I invoke simplest. Okay, and so you see that behavior. So just keep in mind you got asynchronous code running here, and the function continues executing, and you've got that callback where you can do what you need to do. Now, for the most part, one thing to realize is that in a lot of your Angular codes, in your Angular components, your goal is to set the state of the object, and you're binding the data to the template using directives. So as far as when you want that result to happen as fast as possible. So if I called a web service and I wanted the result to happen, that goes without a given. Speed is of essence. But the thing is, you're trying to set the state of the component, and the property binding and the browser re-rendering, the DOM values, property values and stuff, all that's going to happen implicitly, automatically. So there's a lot of things going on behind the scenes, and the way you code in Angular is you basically do things asynchronously. You let it set state, and you let it render the way you want it to render. Okay. Let's look at the next example, which is basic. I'm going to click on this button, basic, and I'm going to invoke the basic function, and basically let's take a look at what I'm going to show you there. Okay, so I have a basic method. I log basic. Now I have, I'm introducing a little bit of logic here. I let this variable isDadEmployed be equal to true. Then I define a new promise, will son get toys? And I'm going to promise that they will if dad is employed. And so if dad is employed, I basically create this toy object and I resolve it, which means that I'm returning a JSON toy object upon resolution. If dad is not employed, okay, then I'm going to give a reason I'm going to reject. Okay, so will son get toys? I'm going to reject it if dad is not employed. I'm going to say there's an error. I'm going to throw an error. I'm going to reject for a particular reason. Okay, now the next thing I do is I go and I consume the promise. Now, I'm not too crazy about wrapping and unwrapping. I personally don't like looking at code like this. I like looking at flat stuff. I like looking at simple stuff, coarse grain stuff. But let's just show the example. So here I do a find result. I define a function, and this function, when it executes down here, it will consume this promise by taking the promise and calling the callback. And so what the callback does is the callback, upon fulfillment, it'll execute this function with the good news, and I'll log the promise is resolved, son will get the toy, and I'll show the toy. Notice, my argument's good news. My previous promise had resolved an object toy. So upon successful resolution, my toy winds up being this object called good news inside my callback. And of course, if there's an error, I catch it and I pass it to some function which processes the error. In this case, I console.log the error.message. Okay, so upon find result, there's a lot of things happening, right? Okay, so I invoke find result, and basically this particular promise gets consumed, the callback gets invoked, etc. And then I do a console log and basic. So once again, that is employed is true. Will son get toys? A new promise. Function of resolve and reject. If that is employed, we define a toy, we resolve it. Else we reject and we give a reason. We consume the promise with a find result function. We execute the find result function. Then we log end. Okay, so let's take a look and see what that looks like when you execute it. Okay, let me clear out the console, and now let me execute basic. Begin basic. Basic promise is executing. End basic. Promise resolved. Son will get the toy, and I display the toy. Can you notice there really is no set timeout here, so there's no lag to see this, but you do see that the function ends before the resolution. So the function continues processing before the callback gets called. Let's try it again. Very quick. Okay, so let's go back and take a look at it. Does this make sense? Okay. Is that employed? Will son get toys? This new promise happens. This executes immediately. Basic promise executing gets logged. Then this thing gets resolved. And this is the callback, but this winds up logging first before it gets caught and this executes. So there is a lag there, and I just want to point that out. Okay, so let's change the logic a little bit. Let's make this false. That means dad is not employed, and the son will not get his toy. So let's take a look to see what happens. The code transpose again. We click on basic. Basic promise is executing, and basic dad is not employed, son will not get toy. Okay, I'm going to go back now, and I'm going to switch that back to true. I'm going to move on to the next example. Okay, the next example is the same as basic. The only difference is I'm doing this chain. And the chain is, instead of consuming the promise and the callback happening, the callback happens, and then what I do is I invoke another promise. Okay, so what's happening here? The promise resolves with an object. Let's suppose it's a toy object. It's a JSON data. And basically what happens, upon success, it goes through and it turns into good news, and it goes into this particular function, and we log that. And then it goes into, and it goes into tell friends, which is the promise I defined up here. Now notice, function is toy up here. So upon success, this callback happens. The good news gets logged, and then then we could tell friends. Tell friends. The toy comes in. Right now, I'm just logging a message, but toy is accessible. Okay, so let's take a look a little bit just to make sure you understand this, because I might have not pointed it out, but here let's take a look at it. This is the promise, new promise, resolving with a toy. Upon callback, I make sure I get a handle on that toy. So I have this function with the argument. Now, I don't necessarily have to do that, but what the heck? I'm going to log the toy. I might as well get the toy in the callback and log it. So that's what I do. And if I want to tell friends, and I do want something similar, to tell friends promise that I'm defining here, could also take a toy argument when I'm consuming it. But I don't use that toy object. All I do is I log a string. Okay, so let's take a look at that now very quickly on the front end. Here's my chain. I'm inside will son get toys. Here's my toy. End chain. I log in the callback. I log the toy object. I'm inside tell friends dad bought me a new toy. Okay, so there's the chain was this as well as this. Okay, so let's take a look at what happens if I change the value of dad is dad employed. I'm going to change it to false. Now I'm going to see my app retranspile. I'm going to do a chain. Click. Begin chain, end chain. Dad is not employed. Son will not get toys. So it didn't even go through the chain because the chain only happened during a successful route. It just went and rejected. Well, let's just verify how that could have happened. I rejected here. So this code did not execute. And this executed. Okay. I know that the chaining is a little bit odd, but the next example is going to really clear things up. So let's take a look at the next example. Okay, what I'm going to do is I have another chain, and this one is very nice. Let's go down to the bottom of this. Here's another chain. I do a console log begin another chain. I have method 1. I instantiate a promise. I have a resolve and reject. I set the price equal to $110. So I set this timeout. After 2 seconds, I resolve that price. I define it to be 110. So I resolve with this particular JSON object. I say, okay, after 2 seconds, this is my resolved price. Okay, and then I do method 2, which is another promise, right? And in method 2, I take the function, and it's consuming a promise, but it's getting a handle of the data, okay? And in that function, I instantiate a new promise, and I say I'm going to add tax to this price. Okay, so during the set timeout function, I log method 2 is completed. I should say completing. And I resolved the taxed price is data.price plus 6. I'm just going to add $6 to this temporarily, okay? So I take the price and I add 6, and I'm resolving that. And that happens after 3 seconds. Then I define a method 3, which consumes a different promise, and that adds discount to the tax price First, I log my tax price. So I have a function which has my data coming in. That I'm claiming that's the JSON object from the previous resolve, and I do a dot tax, my data dot taxed price. And what I do is I resolve after 5 seconds. I resolve an anonymous function by defining a discounted price, which is my data dot tax price minus $10. So what I'm doing is I'm processing this number. Each resolve gets some data. I process it and change it. I do another resolve. I process it and change it, etc. And I return a promise here. Okay, so now here's what I'm executing. Method 1. Then I chain it. Method 1 defines the price. Price is 110. Then I change it to method 2. It adds tax. I chain it to method 3. It discounts the price. And then I finally define this callback, which takes the resolved, I'm going to say filtered value with these promises, and I show discounted price received is the following. And I log the string, or whatever this object is. Okay, so let's take a look at that and take a look at see what that happens. Here's another chain. Begin chain. I'm setting the price to 110. Method 1 completed. I add tax to this price 110, and I get 116. Then I discount the price. I get 106. So this final callback displays the processed result. So started out with 110, I added 6, I got 116. I subtracted $10, I get 106. Now my logging and stuff is not right. I don't really care for this. Let me see. I could fix it, but let's just go through it again, and maybe I'll tweak it a little bit. Okay, method 1 is the first one that's going to execute. I'm going to say method 1 is completing. I'm going to say setting price to 110. Okay, now here's where things get a little bit confusing. Yeah, let me do this. I'm gonna say let's try this. Method 2 starting. Method 2 completing. And now I'm adding tax to this price equal to this. I'll just leave this alone. I think there's better ways to do this. Okay, now in here, method 3 starting. Method 2 starting. Method starting. Okay, now there's something that was bothering me. I before E except after C. put here final. Okay, let's see what happens with that. So we should transpile again. Let's invoke the method, another chain. Begin. Okay, we could slow it down, but let's just look at the output first. Begin another chain, method 1 starting, setting price equal to 110. When I resolve that, I resolved it with a JSON object of 110. Method 1 was completing. Now method 2 is starting. I'm adding tax to that price, 110, that method 2 received from the prior resolution, right? So method 2 completing. But I've already added the tax to 110, so it should be at 116 when method 3 starts. I'm adding now a discount to that taxed price, which is equal to 116. And method 3 completed, and now my final discounted price is this JSON data, and the price is at 106. Now notice I've got some synchronization going on here where I have these timeouts happening. So let's try to slow it down a little bit. Let's suppose this is 4, this is 6, and this is 15. Let's see what happens. Begin another chain. Method 1 is started. I'm setting the price. Method 2 starting, adding the discount to tax price, and then it should come down to 106 rather. Okay, so notice my timeouts are happening. And so there's things going on here. Asynchronous functions, callbacks. Asynchronous functions, callbacks. But we're also chaining. So there's some synchronization going on here, right? Okay, so the bottom line is this: that when you look at this function, call, in some sense, this is being done in a waterfall fashion, right? I mean, method 1 executes. It's executing asynchronously, but it's got to be resolved. It's got to be resolved in order for method 2 to get the resolved value. Method 2 starts happening. It's an asynchronous execution, but it has to resolve in order for method 3 to receive it. So then finally the callback after those 2 happen, or those 3 happen, 1, 2, 3. The callback to log the final discounted price is received. So just keep that in mind. Okay, so let's go back and take a look at our final example. Okay, so what we're going to do is we're going to take a look at this function. Okay, now I have a function here called async await. And my button async await invokes this function. Okay, so let's take a look at what this function does. First of all, I log begin, I log end, okay? So I have a function called resolve after 4 seconds. Let's change this to a 4. Looks like I might have changed that last example. Okay, so basically I instantiate a new promise and I return it. And what it does is it does a resolve. I use this fat arrow operator to invoke this anonymous function, the argument of the function is resolve, and when this gets instantiated, this method executes. And so what I do is I do a set timeout, and after 4 seconds I resolve this x value. So resolve after 4 seconds x, all it does is use a set timeout to submit a resolve of that value x rather, in 4 seconds. Okay, this function is consuming a promise and it's returning one, and basically the instantiation of that promise invokes an anonymous method, and what it says is it passes in a resolution value to a set timeout function, which resolves to x after 4 seconds. Okay, now we then define an async function, and this function here has to return a promise. And so what we do with this is we call it add1, and it has an argument x which you're returning, but you have to add a and b to it. And a is a constant, and it's an await expression. You resolve it after 4 seconds with this 10 value. So a would wind up being 10 after 4 seconds. But this function, execution, at this line waits for this promise to be resolved. And so after 4 seconds, a will be defined, the execution of the function continues. Constant b is equal to await, resolve after 4 seconds, 20. 20 just comes into this function and resolves it as 20. So the resolution of this is going to be 20, and that's going to happen after 4 seconds. Okay, so now 8 seconds later, I'm adding these 3 values. I cannot return this add because the await is holding up, waiting for the promise. This await is waiting for this promise. So here I'm waiting 4 seconds, here I'm waiting 4 seconds. After 8 seconds, I'm returning the sum of these 3. Okay, so this line here, when I add 5 in, I'm adding 5 plus 10 plus 20. It's going to print 35 after 8 seconds. This guy is the callback for this async function. Prints 35 after 8 seconds. Now, okay, so this is like a waterfall. This promise happens asynchronously, give me the result. This promise executes asynchronously, give me the result. But I'm waiting for them. So I gotta wait for this line to execute and finish 4 seconds of the wait. For this line to finish 4 seconds, and then I return this 8 seconds. I'm adding up these 3 values. Okay, so that's what this particular method does. Here's a different version of an async method, and the method is called add to concurrently x. And here, both of these resolve take 4 seconds because they're doing a set timeout on 4 seconds and just resolving that argument. But they're both happening concurrently. because there's no await expression here. But the await expression is here, which means that if I'm adding these three values, the x came into the argument, I have that immediately. But the p underscore a, I'm waiting for that. And so I've got to wait 4 seconds for that. And here the wait is waiting for p underscore b, which takes 4 seconds, and I have to wait for that. But turns out that each 4 seconds is being done concurrently. So I'm going to claim that when you add 2 concurrently to 10, you're adding 10 plus 5 plus 15. You get 30, but it's only going to take 4 seconds, supposedly, because these two resolve after 4 seconds are happening concurrently. It's only you're syncing up when you're going to add the sum of the two. So it's just two different ways to use async functions, doing a waterfall method and a parallel method, and then I log the end of the async that way. Okay, so let's go and take a look at the application code and take a look just to see what happens here. So I click on this button, begin async wait and sync wait, async wait. I get 30 for the first sum, and I get 35 for the second sum. Now, I'm not going to go through and try to prove to you that one is faster than the other. As a matter of fact, I can't really do that right now, nor do I want to, because I'm on a single CPU system, and I'm not on a multi-processor machine. These things don't take much time at all, so there's more setting up than actually executing. So let's not worry about that. But just I want to point out that you are looking at a waterfall method versus a parallel method. And keep in mind that when you're calling web services, you're using observables. So you could use the RxJS package to call concurrent and waterfall style methods and do aggregations on results of web service calls, etc. Keep that in mind. Also, when you're working with Node, there's an async module which you can use, and you could do a .parallel, you could do a .waterfall, and you could call 5 different web services and sync them up, or run them stepwise, or run them in parallel. So pick your poison. I like clean code, and when I'm dealing, the other thing you have to realize is that a lot of stuff we're doing on the client side is very TypeScript oriented, and you could be running Node 4.3 or Node 6 on the back end without using TypeScript. So you got to consider that. So let's just end this example now. Let's go through it. Let's just look at it once more. Let me clear the console. I have an async wait, functions executed, and now I get an async result, waterfall style, and now I get an async result concurrent style. And you might think that the second one was faster than the first, and you should try to convince yourself that is the case. Okay, that'll be it for the tutorial. If you want to complete a demonstration and training on promises, you can go to our anglerorange.io site and take the course. Please register, and there's courses there that you can take. I will post this on our tutorials page as well as it residing on YouTube. Thank you.